So let's start going over this. Okay, so this is it's designed to be like a post test where it's like, okay, here are the concepts that we should walk away from here, that we should have. Can I do these? So each one of these has a learning target, like can I do this? And then an example. Now, each one of these is an example, but it's not everything, right? So for instance, this first one. Oh. Did I just unpause it again? All right, so this first one, right? It says I can identify the 3 forms of quadratic equations and convert to standard form. That's a lot of, there's 3 different forms, right? There's vertex, standard, intercept, and then each one of them can you convert? Can you convert to standard form? Can you convert standard form back to intercept form? Back to vertex form? All those different things, right? This is going to be one example, right? But there are a bunch of different things about converting. So maybe you can do this one, but maybe you feel like, I still want to practice converting. I still want to make sure I'm good at that. So you can write a little note to yourself on this, okay? But we'll do this example, right? Okay, it says convert the following to standard form. The first step when you're converting is to recognize what form you're starting in, right? So what form are we starting in here? Vertex form, right? We know that this is vertex form because it's y equals a times x minus h squared plus k, right? We know that's the form we're starting in, and we want to convert to standard form, meaning we have to get it to be in the y equals ax squared plus bx plus c form, right? So we need to get it from this parentheses squared situation to the full trinomial, okay? And there are steps for that we all learned, right? The first step when I'm converting, I'll zoom in a little here, when I'm converting that to standard form, the first thing I need to do is what? Pull it apart, right? Expand it, pull it apart. What can be pulled apart here? Yeah, x minus 5 squared. This part right here can be pulled apart. So this becomes negative 4, and then x minus 5 plus 3, right? So I'm on my way, right? First step, all you gotta do is pull things apart, right? But then why did I pull that apart? What's my next step? Yeah, box or foil this part, right? If I know I pulled this apart for a reason, it's so I could see what I need to box or foil. So I feel like I do foil a lot here. So I'm going to do box for a sec here. X minus 5, make a box, right? And then I put x minus 5, x minus 5, and then I just fill in each box by multiplying. X times x, that's x squared. X times minus 5, that's minus 5x. X times minus 5 is minus 5x. Minus 5 times minus 5 is plus 25, right? Minus times a minus. And then I know that these always come together, and I get x squared minus 10x plus 25. So what did I just figure out? I just figured out that this times this is this. So I can put that right there, right? So I plug that in, y equals negative 4, and then big parentheses, and I plug that in instead. X squared minus 10x plus 25, and then I still have this plus 3 on the outside, okay? What's my next step? What do I need to do now that I've figured out what that is? Yeah, I got to distribute this negative 4, right? This negative 4 is being multiplied by everything here, so I need to do that, right? So it becomes y equals negative 4 times x squared is negative 4x squared. Negative 4 times negative 10 plus 40, yep, x. And then negative 4 times positive 25. Negative 100. So the reason I dropped the parentheses is when you distribute, you can get rid of the parentheses. But I still had this 3 out here. That needs to come down, right? Now, the only thing I have left to do is just simplify this a little bit, combine what can be combined. What can be combined here?
Negative 100 plus 3.
Yep, negative 103. You can bring that together. So that's y equals negative 4x squared plus 40x.
Minus 97.
Minus 97, good. And now I have it in standard form, okay? Now, the question if you could do that, great. The question you want to ask yourself leading into the test is, could I convert that back, right? Could I convert that to intercept, right? Could I go from intercept to standard, right? Can I do all the combinations, right? And that's when you want to look at that graphic organizer and just make sure you understand everything on it, okay? All right, so that was our first learning goal. If you were able to do that, great job. Our next one, can I identify key features of a quadratic function? So again, our example is going to be in a certain form, but you want to be able to pull out the pieces from every form, from standard form, from vertex form, from intercept form. What form are we dealing with again here? Vertex, right? So this is just an example of pulling out from vertex, but can you do it with all three? Okay? All right, so for our example, well, it says we have y equals a times x minus h squared plus k. We know that's our form, and then we have our equation that they gave us. It said find the vertex and the axis of symmetry. So we need to find those pieces and then figure out what those pieces are. Okay, so our pieces, well, the first thing I always want to do is just pull them out. My A, my H, and my K. Step one is what are they? Can I identify them? Right? What are they? So what's my A here? 2, right? And then my H? 3, positive 3, and my K? Negative 4. Now, a common error here is to put negative 3. Remember, anything inside parentheses, whether it's intercept or vertex form, if you're pulling out a number, you flip the sign. Okay? You're pulling out a number inside parentheses, you flip the sign. Okay? Now, what are these? What's the significance of each of these things? Like, what does the A represent?
The stretch.
The stretch, and then if it was negative, it would also be whether it reflects. Right? This one's not negative, so it does not. Okay? And then my H and my K are my what? They're the X and Y of my vertex, right? Okay, so step one is pulling the pieces out. Step two is thinking, what do these pieces mean? Like, why did I pull these out? Okay, so this asks me to find the vertex, right? Well, if our vertex is HK and we found our H and our K, we know our vertex. What is our vertex? 3, negative 4. Okay, now the axis of symmetry. How do you find the axis of symmetry? This was a spot on the quiz I think we got confused.
It's the x.
In your vertex.
Yeah, it's the x value of your vertex. If you're ever not sure, draw yourself a picture, right? So this thing would look like this, right? I know that it has a vertex of 3, negative 4, and I know that the axis of symmetry goes right down the middle, right? So I've drawn myself a picture. I also know that the axis of symmetry is always just like x equals something. Well, what is x at that spot?
3.
It's 3, right? It's the x value of your vertex, right? So our axis of symmetry is x equals 3. I didn't see a lot of pictures drawn on the quiz, and I feel like, especially the max and min problem that we're going to do in a second, drawing yourself a picture would help you not make a mistake, okay? So make sure you do that for yourself if you need to. Any other questions on this one? Okay. Our next learning goal. I can find the max and min values of a quadratic function in any form, right? So what form do we have here? Standard, right? So that's y equals ax squared plus bx plus c. Right? And it says find the max and min value, or minimum value, and then it says determine the range. So we have two things we need to do. Now, whenever I find my form, the first thing I always want to do is pull out my pieces, right? Find my A, my B, and my C. What's my A, what's my B, and what's my C in this case? My A is 1, right? Because when there's none, there's 1. My B is negative 4, and my C is negative 2. Okay, so I pull out my pieces. Now, for a max and min problem, this is why I say it's good to draw a picture. What do I know will determine the max or the min? Like whether it has, because we have two possibilities here, right? I got either, I'm going to have this parabola or this parabola, right? Yeah. Concave up or concave down, right? How do I know which one I have? Because that's my first step. Do I have that one or that one? Yeah.
The smiley face is a positive and then sad face is a negative.
Okay, so the green one is a positive what?
It has a positive X. No, it has
Not
a
a positive X.
A.
A value, right? This one, that means my A is positive. And this one would be my A is negative, right? So which situation do we have? We have a positive one. We have this green one, right? So think about it. Is that a min or a max? It's going to have a min. It's going to be really high. It's going to go down to a min, and it's going to go really high. This one will be really low. It'll go up to a max, and it'll be really low again. So this will help you determine min or max. So the first thing I need to do is that. I know I'm going to have a min, right? Because I have an A value that's positive. First step. Now, what is that value, right? If these are all vertexes, so this would be x, y, and this is an xy vertex, right? We know that the vertex is involved in the min or the max. Which part of it is the minimum value? The y value, right? The x just tells you this. The y is telling me how high or low it is. So we always want to pull the y for our minimum or maximum value. If we need to know the y of our vertex to find our min or our max, that means we need to find our vertex, right? So we're going to find our vertex. Right? We need to know what that is. There's two ways to find it from standard form. There's the old way and the newer way. Who can tell me one of those ways? Layla.
Negative b over 2a.
So, correct. What exactly is that finding? The x of my vertex, right? So the x of my vertex I find from x equals negative b over 2a, right? And then once I find that, I find the y by plugging it back in, right? So we're going to do negative b over 2a first. For this one, that's negative, and then what's my b?
Negative 4, so positive?
Yep, negative 4 over 2 times 1, which is positive 4 over 2, which is 2. Okay? Now, that from finding my vertex, I found half of it. I know my vertex is 2 something. To find the y, what do? I plug in. So y equals 2 squared minus 4 times 2 minus 2. Right? That gives me the y of my vertex. Okay? Zoom out a little bit here. Okay, so that would be 4 minus 8 minus 2, which is negative 6. So my vertex is 2, negative 6. Right? That's what this point is right here in my little drawing, 2, negative 6. So what is my min value then? Negative 6, right? That's how low this thing goes, right? So to answer the question, I would say I have a min of negative 6. Now that's only one of the questions, right? There was a second question. What did it ask for? The range, right? It actually didn't ask for the domain, but we know the domain of any parabola is all real numbers, right? The range is always y, some inequality symbol, and then our min value or our max value. So negative 6. So I have to just decide what goes in the middle there. Greater than or equal to or less than or equal to?
Greater than or equal to.
I have the notes.
Greater than.
Okay. So why? I'll let you tell me why.
Isn't it because if it's min, it's greater than?
Yeah, because if it's a minimum, well, if we think about this, it's either negative 6 here, or it's greater than it, 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 or it goes down to negative 6 and then it gets greater than it again, right? Well, in inequality terms, that means it's greater than or equal to negative 6, right? So greater than or equal to negative 6.
Because it's a min, you can't go.
You can't go lower than that. Question.
Why is our min negative 6 again?
because that's the y value of our vertex. This thing goes down, it gets down to -6, and then it goes up, right? When we're talking about our min or our max, we're thinking about how high or low it goes, right? And our y tells us how high or low it goes. Y is the up and down one, right? X is the left and right one. Okay, so that's our range, okay? Now, you could have done this another way. You could have said, well, I know that I need the vertex for this. Why don't I just convert this to vertex form? So let's do that. I'll do that. We'll do that over here. All right, so if I have y equals x squared minus 4x minus 2, and I say, okay, I want to convert that to vertex form. Standard to vertex. What's the process for that? Completing the square. First thing I do when I complete the square is I kick out the c. So y equals parentheses x squared minus 4x. Leave a space, kick out the c. Okay? The next step here to complete this perfect square is I need to put in something that will make it a perfect square. So I do b divided by 2 squared. My b is what? -4 divided by 2 is? -2 squared is 4. So I would add 4 here, and I would subtract 4 on the outside. Just plug it in, and then subtract it out. Okay? Now what happens is on the outside, I have -6, right? And on the inside, I have x, and then b divided by 2, which is -4 divided by 2, which is -2. Now I have this in vertex form, right? Well, I was looking for the vertex, right? So I could say my vertex is 2, -6. Draw myself a picture, figure out if I have a min or a max, and then I pull that value, the y value of my vertex. Question? Okay. So that's just another way to do it. 2 different ways, right? To get to that vertex. Okay? All right, moving along. The next thing, can I graph quadratic functions in all 3 forms? Again, this example will be one form. If you're studying, you got to make sure you could do it in vertex form, standard form, and intercept form. Okay? Which form do we have here? Intercept form. So y equals a times x minus p, x minus q, right? So the first step that would be a good step to do is pull out my pieces, my a, my p, and my q. What's my a here? -1. And what does that tell me? It means it's flipped down, right? Concave down. And is there a stretch? No stretch. That's nice. Nice and easy. All right, my p and my q. What did I say you have to do when you pull stuff out of inside parentheses? Flip the sign. So if it says x plus 5, my p is -5. And if it says x plus 1, my q is -1. Okay, great. So we pulled them out, but what do they represent? Our x-intercepts. So we can start graphing now. We're almost there. -5 and -1. Those are my x-intercepts, right? Now, what else do I need to graph? I can't just use my x-intercepts. I need more than that. I need my vertex, right? There's a formula for vertex. Yep, there's 2 ways to find it in this case. The first way would be x equals p plus q divided by 2. In this case, that's -5 plus -1 divided by 2. That's -6 divided by 2. That's -3. So my vertex is -3 something. When I have my x of my vertex, to find the y of my vertex, I plug it in. So I would say y equals, well, -3 plus 5, -3 plus 1, and then that's -2 and -2, or +4, right? -2 times -2 is +4. So my vertex is -3, 4, so I go -3, 4. Now, what else could I have done here? Use my A, what else?
You just look on the graph if you have a graph.
Mm-hmm.
The middle
Yep.
of the two.
What's in the middle of -1 and -5? -3. So that has to be my axis of symmetry. It has to be the x of my vertex. Then I can plug that in to find my y. What else could I have done?
Because you know kind of like the rules of if there's no stretch pattern,
Mm-hmm.
where it's because they're 2 away from where the vertex would be, it means you go up 4 and then
Yep.
over 2.
So thinking about this, like now that we know the vertex is over 1, down 1, over 2, down 4. But once you have the x-intercepts, if you know it's 2 away, you could go back to up 4 as well, if you could recognize that. That's hard to recognize sometimes, so you don't need to know how to do that. But it's also a nice way to check your work once you're done, because you know your stretch is -1. Well, now I can make sure that this fits. Down, it goes going down, and it's over 1, down 1, over 2, down 4. Okay, that lines up with what I knew my A value was, right? Okay, and then we could add, we could go over 3, down 9, but we don't have to. Okay, so now we have our parabola graphed, right? If this was in standard form, you would do -b over 2a, find your y, that gives you your vertex. If this was an intercept, or it is an intercept, if this is in vertex form, it gives you your vertex. Just put it on the graph and use your stretch. Okay? All right, last one, unless there are more questions here. All right, last one was the last thing that we did in this unit. I can write equations of quadratic functions using vertices, which is the plural of vertex, just means multiple vertexes, and points and x-intercepts. So there'll be 2 scenarios here. There will be this scenario where it gives you a vertex and a point. The other scenario will be it gives you 2 x-intercepts, so 2 points, and then a third point. Right? This is one of the scenarios. Now you're either going to use vertex form or intercept form to do these. Okay? This one gives me a point and a vertex. So which form do you think I should use to try to figure out this problem? Vertex form, it gives me the vertex, right? So y equals a times x minus h squared plus k. Now I'm trying to find a. So I really want to be able to plug in for everything else. So what does the point give me? What is it? It gives me an x and a y. And then what does the vertex give me? My h and my k. So I can plug all those in. All I'll have left is a, and then I solve for a, right? So I'll do them one at a time. I'll do the vertex first. So y equals a times x minus 2 squared plus 3. Now I plugged in my h and my k. Now I want to plug in my x and my y. So 5 equals a times 4 minus 2 squared plus 3. Now all I have left is my a. I just solve for it, and I have my equation. Question?
Does it matter if H is 3 or K is 2, like you flip it, or?
It does, because this is your vertex, and x and y are a point. Okay? All right, so now I just solve this out. So this is 5 equals a times 2 squared plus 3, right? 4 minus 2. 2 squared is?
4.
4. A times 4 is just
4a.
4a, right? So this is 5 equals 4a plus 3. So minus 3 from both sides. I get 2 equals 4a. Divide by 4, divide by 4. Yep, and I would get a equals 2 over 4, which of course reduces to 1/2. So I have my a value. I already had my h and my k. Now I just plug them all into my equation, and I get y equals 1/2 x minus 2 squared plus 3. And I've written the equation that would go through that point and have that vertex. Okay?
How come when we write this thing, how come we just don't put X and Y in?
Why don't I just do it all in one step?
The green box, why don't you just fill in X and Y if you know what it is?
Because that's only one point. I'm trying to make an equation for the whole parabola.
Oh, okay.
That would be 1 point on the parabola.
Okay.
Good question, though. Okay. So that is this thing, right? This can help guide you in what you need practice on. What can also help guide you is the review homeworks that I'm going to give today and tomorrow.